So in case you haven't heard already, I have reluctantly decided to cancel the launch of the Shru7i drone synth I demoed in a previous video over logistical problems and a general lack of interest. So I've decided to salvage this as an educational experience and show you how it works. So the basic principle of operation is this Avalanche oscillator section right here. So you have your switch, your enable switch right here, which enables and disables the oscillator, and you have a current limiting resistor right here, because if this goes down to zero, goes down too low, this transistor will pop, as I have discovered while on the breadboard with this thing. So this is a 10K pot right here, and this 100K resistor helps reduce the levels and prevents the oscillators from interfering with each other on the audio bus. So this capacitor, which actually in the previous video where it was demoed, is actually 4.7 microfarad, not 10 microfarad. My original design had 10 microfarad, but I had changed it. And anyway, this thing gets charged up at a rate determined by this rheostat and resistor in series. So this section gets charged up, and when it gets to a certain voltage point, this transistor goes into Avalanche. If you notice, it's kind of wired kind of weird. It seems wired in reverse polarity. That's because a lot of bipolar junction transistors have a property known as reverse avalanche. So when it gets to a specific voltage, it acts like a threshold switch and dumps this capacitor to ground, creating essentially a sawtooth wave. And I've got 7 of them, and they're connected on a common 15-volt bus, on a common ground, and a common audio bus, as you can see by this tag. Down here is just some power supply decoupling here, and an output coupling, because this thing, it does have a DC bias. I mean, it all happens above 0 essentially, because this is all single-sided. Anyhow, we can just have a quick look at the PCB. I mean, it's nothing remarkable. As you can see, I did some things with a copper layer and the solder mask layer. See, front mask, it shows right there. So pretty much there's the audio bus I was talking about. And you notice these traces, I actually use any angle routing right here just to keep everything nice and short. And of course, everything right here was able to be arranged ortholinear. So that was kind of cool. I probably would actually have a little bit of a bridge here, you know, have it arc right there, just so it's not so close to this pad if I were to redesign it. But it doesn't seem to have caused an issue. The main concern with this design is that bridging right here, the default TO92 package in KiCad is like really close together. I know they have an alternate staggered one, and in my future designs I definitely will use that, because when this thing generates, of course, output Gerbers, it actually takes away solder mask right here. If it had solder mask with that little sliver, and keep in mind JLC PCB, I'm not sponsored or anything by them, but they're still my go-to board house. They can actually do little slivers like this without a problem. Their specs are actually pretty decent. And of course, I got my 15-volt pour right here, and of course you can see my little design. Let me go to rear copper, my design, my little stamp on the back. I had this cut out because I originally wanted to have it so if you could backlight it, like this text would shine, would kind of be silhouetted as a little thing, because I needed to put a stamp here anyway where it wasn't around all this stuff, because this design is pretty, you know, it's a thing. 3D viewer, it doesn't load the potentiometer and switch footprints, because they're kind of specialty. Same with the jack and the audio out. But yeah, that's pretty much how it works. And by the way, this configuration is also known as a negister. Don't remix that, by the way. So, you know, essentially it kind of acts like a tunnel diode in a way, but without it being an expensive tunnel diode. So it's kind of a neat feature because you can make like really simple oscillators, even LED flashers, if you use a high value cap and high value resistor, like let's say 56K or something like that. You could like have a slow, well, it's more of a rising flash. If I show you the waveform, it's not actually quite as smooth. You'll notice because the way that it charges, this is actually slightly curved on the top, so it's not a true sawtooth, because the rising edge is actually an arc, and you can sort of see it in this image. But yeah, that's how this thing makes sound. I am planning on, as a personal project, building a synth hurdy-gurdy-esque device. Yeah, I have some plans for that, so definitely stay tuned in the future. I might integrate this as the drone section. Well, everyone, I hope you liked this video. Don't forget to like, comment, and subscribe, and definitely don't forget to hit that bell. Until next time, thanks for watching.